Okay, let's get going here. It's 5:28. This is video 108, and I'm doing the work on assignment number 40, and hopefully this will help you out. I'll go over 1, 2, 3, 4, the first 6 briefly. We'll double check that we got everything down here by using coprimeness as I taught you before. So let's go to the first one, which I'll work a little bit in detail. I'll move it over here so you can see what I'm doing. And here, I'm going to do it the old-fashioned way. If you couldn't do it in your head, there's 12n to the third. Underneath, I put 36n squared. You can see that up here, yes. And finally, positive 8, 18. Notice the n's don't share in all three, and they share the 6. So there's 6 times 2, n, minus 6 times 6, n, and finally 6 times 3, no n's. So remember, when you factor monomials, one term for the GCF, all 3 numbers have to share all 3 rows. Otherwise, it doesn't matter that they share 2 rows. 2 times 3 equals 6 here. There are 2 rows matching, but that doesn't give you a GCF. It has to match all 3 rows. So with that in mind, I work backwards. You can draw the arrows and see what's going on. Okay, all the terms are correct here. All I could match was the 6. So this, the 2, the 6 and the 3 is circled. You just write them out if you're doing it that way, and the check is right there. For number 38, and I look at 40, 25, and 80, 0, 5, numbers ending in that can only be divisible by 25, 5, or multiples thereof. But as we can clearly see, 25 doesn't work, so 5 does. So 5 is the GCF. Everybody shares at least an X. So I'm not doing that on the board. I'm leaving that one to you guys to double check that I did it. And certainly the check works. 18, 5, and 16 are coprime. That is, all 3 numbers are coprime. I know that 16 is a multiple of 8, but it has to work for all 3. So this passes all the tests that we wanted it to do. Now we turn our attention to number 39, and there's room for mistakes there. You might look at that and say 7's the answer by inspection, but if you do 7, you're going to get coefficients of 6 goes into 7, 42 7 times. Excuse me, 7 goes into 42 6 times. I'm just working quickly on the board here so you can see why 7 doesn't work. And 7 goes into 56 negative 8 times. And then a plus 4. Well, see that? 6, 8, and 4, they're not coprime. So that's telling you 7 doesn't get the job done. So when I put everything together, 14 turns out to be the GCF. Double that. Because when I write everything out and I match everything, which is a good example of why you have to be a little careful with this. It's easy enough to make a mistake, but coprimeness always gives you the work that you need. So let's try the 7 times 2 times 3. That's 7 times 6. And I'm just writing it out. And then 7 times 2 times 2 times 2, which is 7 times 8. And finally 7 times 2 times 2, which is 4. And you see the 14 is the number that works. I extract the x squared and work backwards using the product rule. And I see that that's the correct answer. Okay, so there's room for error here. You got to be careful. Got to make sure that you're doing all the work. You're watching all the terms. It's easy enough to make a careless mistake. Number 40, there are 4 terms here, 3, 4, 5 terms. It doesn't make a difference in math. And as we can see here, I extracted 3c, and if you multiply backwards, 5, 8, 2, and 6, together, taken together, are coprime, because no one number except 1 divides all 4 terms. This works for 5, 6, 7, 8 terms. So you can see I have that. You can work it backwards as we go. Let's see. This would be 4, not 6. So easy enough to make a mistake. 3c times 4. So I fixed that up real quick. Easy enough to make a mistake there. But it doesn't change the underlying reality. 5, 8, 2, and 4 are not coprime taken as a whole. Then I go to the next one. 2 is the GCF of 8, 4, and 6. So I extracted the 2M. What's left, you can check it as I work backwards. This problem 42 is very similar to 38. Again, they're all multiples of 5 because they end in 5 and 0. And I work backwards, again checking for coprimeness, and hopefully there's no mistake there. It doesn't look like it. So there's the math properly factored. Okay? So I'll take a little bit more time now, and I'll work on the last two, which seem to give kids a bit more trouble. Okay? Really nothing going on though with two variables. Really, to be honest with you, you got to get used to two variables. Don't get me wrong. 8th grade math is all about doing that. 2, even 3 variables. And so we've been introducing them to you. And actually, as I said before, as I stated before, you're just working off the Regents book when you're doing these problems. What they'd expect you to be able to do. Be much like when you work in class, you're all in groups and everybody's sitting around and working on these problems to make sure that any discrepancies are taken care of. We don't have class anymore, so this would have to be a substitute for that. And we'd be hoping and praying that you're doing your work on your own so you can learn this properly. You will see it next year. So let's just get this all down, just cleaning this off a little bit. Worry about the rest of it later. And I'm going to thoroughly, using LCM checks, do 61 and 62. Okay? So let's take a look at 61. Here, we'll do it over here. I'm breaking down the 8 and the 3. If you look at that, they are obviously coprime. So I'll just write out the 8. And without further ado, just start breaking the number down. There we go. So we have 8, M, 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 N, 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 N. So all I did is break these down. I didn't bother to break down the 8. That's just 4 times 2. Or prime factorization would be 2 times 2 times 2. And then the 3, so these numbers are coprime. There's 1 M, and then there are 2 N's. So I match, and whatever matches, matches. That's the way the game is played. So the GCF is M, N squared. What's left? 8. There's circle, circle. M squared, N squared. Move over to the other side. Nothing's left except the 3. Everything's been matched. Okay, so there you go. And we'll quickly do an LCM check. And that would mean Mn squared times 8 M squared N squared times 3. And 8 times 3 is 24. M to the third. Everybody see that? Left to right. N to the fourth. There's your LCM. And now I'll just divide backwards from my original terms. And there we go again. And most of you are paying attention can see this works nicely. I'm moving quickly now since this has been explained. I'm just showing you that it works now by the second term. And there's an M, and there's an N squared, and I'm dividing. So 3 minus 8 divided by 3. 24 divided by 3 is 8, so that checks. 3 minus 1 is 2, so that checks. I'm looking, where's my factorization here? That checks, and then 4 minus 2, and we're all checked out here. Okay? So there's my check. The math is correct. And now I turn my attention to the last one, which I guess is meant to be a little tricky, but numbers can't be that tricky. Okay? The numbers are the numbers. There's no word problems here. The numbers are the numbers, right, guys? So I'm just going to erase this again, and I'll do a LCM check. I think it's important to think a little bit abstractly for these kids. for you kids, I should say. And I'm just taking a second here to clean this board up a little bit. Change the soap next time. But we have enough to get this done so you can see it. So let's take a look at 26. A to the 5th, B to the 2nd, and finally 51, A to the 4th. And if you like, B to the 0, but I don't see the reason to do that. Well, the only factors of 26 are 2 and 13. I read out A 5 times. And again, I keep saying it, but I'll say it again. You can do a lot of this in your head. Sometimes it's not the greatest idea to do all this stuff in your head. Hold on, we got all that there so you can see what I'm doing. And now underneath, 3 times 17 are the only factors of 51. You need to know that. That's 6th grade math. And then we have A. So A matches 4 times. Again, you could have done that in your head. So the GCF is A to the 4th. Nothing else matches. So now I go 26 A B squared. That's what I couldn't match. I'm circling it again. And over here, plus 51, but everybody was matched there. So there's your proper factorization. And we'll quickly do an LCM check. There's A to the 4th times 26AB squared times 51. And to make math easy, I'll just use the calculator here. No need to knock myself out. It's 1326. So it's 1326 times A to the 5th, A squared times A, times B squared. So one more time for the weaker students, this times this equals this. I'm just multiplying left to right, making sure I got everybody there. And now I divide that by my original terms. So I do this. And of course, if we multiplied it out correctly, that's going to equal 51. Just common sense that 26 goes into 326 51 times. You can get your calculator out if you doubt me. I think most of you believe me. And then 1326, A to the 5th, B to the 2nd, again the LCM. And I'll divide that, by the final term here. And so we know that 51 goes into 1326 26 times. Okay, and it's A to the 4th. And I divide that and I get A. And I divide that and I get B squared. Because after all, again, for the weaker students, I'm only dividing by B to the 0. And that's precisely what I was looking for, which you can see over here. Okay, so that's all the problems that I gave you. I said I'm going to give you some more problems a little later this afternoon, and then maybe do them later tomorrow in the afternoon to give you time to do them. And these will be some problems for the book, and the can problem, the soup can problem, and tomorrow I'll do that challenge problem I gave you. So I'll get this posted as soon as I can.